This is Professor Billier at Worcester Polytechnic Institute. This is a tutorial for setting pretest parameters in Blue Hill 2. So we've already discussed how to run a sample, and I've now loaded in a tensile test, and I go into method, and under control, the test is an extension at 100 millimeters per minute. There's an end of test setting here, such as rate of load for failure or a certain extension. I'm going to change that extension to a tensile strain of 5% because I don't want to go to failure for this rope. The rope is very strong. And what I'm going to do change here is pre-testing. So I may want to preload the sample because actually this sample I have is a piece of rope that is slack right now. So I could put a preload and run this and extend it such as 100 millimeters per minute until a load of 5 newtons, and it can hold that load until it does something like auto balancing. So this is another thing you could do, and I could auto balance my tensile strain after putting a preload of 5 newtons. Why would I want to do that? Well, because again there is a slack length in this rope, and I want to get that slack length out. It's even a bigger problem with viscoelastic nonlinear tendons where there can be slack length and relaxation or creep of the material, and it's nonlinear. We have to define when do we actually define zero strain. Now I'm actually not going to do these. I'm going to do this manually. So if you notice up here my load is very small. I'm going to turn that preload off and the auto balance off because I like to know how I'm actually doing the experiment very explicitly and not allowing or relying on any of the slack length correction analysis in the software. I want to do my own analysis. So I'm going to manually move the sample until all the slack is gone. You can see up here that the extension is changing here, and I'm now at 21 newtons. I want to bring it down to 5 newtons or so, which is about a small amount of the load, a 2,000 newton load cell. I can use my fine position here. And then I'm going to reset the gauge length manually. Now I do still, and when I reset the gauge length, it should go to 0. There's multiple ways of doing that. And so I'm at 0 here, and my tensile strain says 3% here for some reason. It should go down to 0. Now I can also pre-cycle, and this is very important for soft tissues where you don't get the same response the first cycle as subsequent cycles, and best practice is to precondition 8 to 10 times slowly, and you can do that to a stress or a strain. I'm going to do it using an extension control because that's very stable on my screw-driven machine, and I'm going to go to a tensile strain of 5% maximum, and the tensile strain go down to 0 at the minimum. You can go to different loads. You can do it on a load control, stress control, strain control, and you can go to load, stress, strain, displacement, any of those. But this is my preferred way of doing it right now. And then now I have that preconditioning, and if I tick this box, capture pre-cycle data, when I go to my raw data and I report out my raw data for export results, and export the raw data, in that raw data file will also be the pre-cycling. Now I can go to my test. I can start my test here. Now I didn't reset the gauge. After I've zeroed the displacement, I need to reset the gauge length. I measured that as 111 millimeters. Using a micrometer, I've already measured the diameter, which is 1/4 inch or 6.3 millimeters. I put the safety stop on, and then I start the test. And as you can see, it started at a small load, only 5 newtons, and then it's going up from there. The displacement is being shown in blue, and the cyclic load is being shown in red. If you'll notice in the last test, I was only set to one cycle of pre-cycling data. Generally, we're going to want to go to more cycles. If I go back to the method, though, now that I've saved it, it won't let me change the method for pre-cycling to controlled under load or to different loads. It will let me change the max or minimum values. But I would like to go this time to 5 cycles and then go back, hit enter, and then go back into the test. Now this is, I'll consider this a new sample. I have to again load it to the 5 newtons and reset the gauge length manually. It's 113 this time, millimeters. Put my safety stop up, reset the gauge length manually, read 0 extension and 0 tensile strain at 5 newtons of preload or tear load, and start the experiment. Now it loads it to the 5% strain, comes down. This is 0 extension, and this is load. So I'm looking at load extension. I could also look at the specimen. This dark red line is this sample. It's loading it from 0 up to 5% strain. It's not hitting exactly 5%. It's going over a little bit. It's doing, you can see the first cycle was slightly different than the other cycles. And it should stop after 5 peaks. 1, 2, 3, 4, 5. And then the last load, that's the actual ramp load. And that's the cycle, the last ramp load where all your calculations are going to be run from. You can hit OK, and it returns the back to the gauge length to 0 tensile strain.